In this episode, we will see how a hospital information system, an HIS, uses a LangGraph-based pipeline to interact with a medical language model running in a confidential environment and generate a structured clinical report as a second opinion for the doctor. In previous videos, we showed how SuperSwarm works. A quick recap. SuperSwarm is a confidential cloud that runs on top of existing infrastructure, whether that's a public cloud or on-prem servers. Swarm runs every workload within hardware-protected, trusted execution environments. This means the model, the data, and the runtime state remain isolated from anyone, including infrastructure providers and operators. And crucially, the confidentiality provided by the swarm is cryptographically verifiable by any external party at any time. Transferring sensitive medical data to external AI services is typically prohibited by privacy regulations. SuperSwarm protects data at all stages and replaces trust in infrastructure providers with confidential computing and cryptographic verification. The LangGraph agent we will see in this demo collects and processes the patient's medical data, then sends it through a verified, secure channel to an AI model running on SuperSwarm within a confidential execution environment. The data is protected both in transit and during computation itself. We've already set up a new cluster in Swarm, allocated the necessary resources, and published it. To make the model accessible, we need two hostnames in our example domain, one for the web UI and another for the API. We added the corresponding CNAME and TXT records for both in our DNS provider. Once that's done, we can start building on top of it. To deploy the solution, we also downloaded the kubeconfig and created a deployment script using a template. To learn more about all these preparatory stages, watch our previous videos about SuperSwarm. An overview of the code behind the LangGraph pipeline is beyond the scope of this demo, but let's take a quick look at the deployment script. We set our domain name and the model, a quantized medgemma with 4 billion parameters pulled from Hugging Face. To run this model, we will use Ollama. We won't be using the web UI here since we're hitting the model through the API endpoint, but the option is there if you need it. Now let's look at the application itself. The HIS interface shows a list of patients currently in the hospital. The doctor opens the patient's card and presses Generate Clinical Report. On the right side of the screen, you can see the execution timeline, a real-time breakdown of every step in the pipeline, explaining what is happening and why. Here's what the pipeline does, step by step. First, input schema validation. Patient data is retrieved from the HIS, including complaints, medical history, medications, and allergies. Then, clinical field normalization. The agent checks the structure and normalizes all fields into a consistent format. Next, agent state assembly. A LangGraph state object is constructed. This is a shared data container that passes information between LangGraph nodes. At the anamnesis structuring step, a clinical narrative is built from the structured fields into a coherent text that the model can reason over. That narrative is then passed to prompt packaging, where it's inserted into a clinical request template. The prompt explicitly asks for a JSON-formatted response. The next two steps call medgemma. Instead of calling the model directly, the request goes through the gatekeeper secure channel setup. The gatekeeper runs on the local machine and verifies the remote deployment before allowing any traffic through. By attesting the TEE environment and establishing an encrypted connection, it creates a single trusted channel between the agent and the model, even though they run in entirely different locations. The model processes the case inside the TEE and returns its raw output. Once the response is ready, the pipeline extracts the valid clinical JSON from the raw model output. That JSON is then checked against the clinical schema. All expected sections must be present: diagnosis, red flags, recommendations, and so on. Finally, at the report finalization step, the complete result is packaged for the UI, including the full execution trace and per-step timing. Once the process is complete, the doctor can review the report, attach it to the patient record, save it to the database, export it as JSON, or inspect the raw model output directly. What you've seen is a deliberately simple LangGraph pipeline to illustrate something important. The patient data is always protected. The agent communicates with the model via a secure channel. The gatekeeper allows communication with the model only after verifying that the service is running in a confidential environment with the expected configuration. There's no manual oversight or operator intervention involved. Within the TEE, everything is run and verified algorithmically without human access. SuperSwarm provides a secure and verifiable way to run AI agents, databases, and other complex workloads. The application may change, but the confidentiality guarantees stay the same. Stay tuned for more practical SuperSwarm use cases. Super Protocol, making self-sovereign computing accessible.